Today we're going to look at how to rationalize the denominator when it's not just a radical in the denominator. So these expressions have like 1 minus the square root of 5 in the denominator. It's not just a radical. So if we tried to turn this square root of 5 into a square root of 25 to make the radical go away, if we multiplied, we would have to also multiply that 1 by something, and then we'd still have a radical down there. We'd constantly be chasing our tail trying to get rid of that radical. So the solution is to multiply by the conjugate. The conjugate is the exact same thing as the denominator with the opposite symbol. So if your denominator says a plus the square root of b, the conjugate would be a minus the square root of b. So if we had 3 plus the square root of 2, the conjugate would be 3 minus the square root of 2. But if we started with something like 1 minus the square root of 5, what would the conjugate be in this case? So we need to multiply the top and the bottom by 1 plus the square root of 5. Okay, on the top, that wasn't a very straight line. On the top, we need to distribute. So 1 times 1 is 1. And 1 times the square root of 5 is 1 times the square root of 5. Do you have to write the 1 in front? No. If it was a 2, you would absolutely need to write that in front. But because it's a 1, you don't really have to write it in front. On the bottom, we have to double distribute or FOIL. I really hate that word, but it actually works here. 1 times 1 is 1. 1 times the square root of 5 is 1 times the square root of 5. Then we need to distribute the negative square root of 5. Negative square root of 5 times 1 is negative 1 square root of 5. Negative square root of 5 times the square root of 5. We need to talk about this. Negative square root of 5 times the square root of 5. Because it's a negative times a positive, it is going to be negative. So this is really negative square root of 25. What is the square root of 25? 5. So this is negative 5. Now the shortcut is, if you see that you're multiplying a square root times itself, that will cancel out the square root and leave you with just the number. So square root of 5 times square root of 5 is 5. Square root of 10 times square root of 10 is 10. If you multiply a square root times itself, it just becomes that number without the square root. So there's the little kind of how-to why we did that in orange. Okay, now let's see what happens. Do you notice anything interesting on the bottom? The square roots cancel out. That's why when we multiply the conjugate is exactly the same, but instead of the symbol, it's the opposite symbol. That way you end up with this plus minus the same term, and they will cancel each other out. So on the bottom, we really just have 1 and negative 5. What is 1 and negative 5? Negative 4. So we have 1 plus the square root of 5 over negative 4. All right. Do you want to try number 8 on your own?
Yes.
Yeah. So pause the video, try number 8 on your own. First of all, I just want to check, what is the conjugate for number 8?
2 plus the square root of 6.
2 plus the square root of 6. Multiply top and the bottom by 2 plus the square root of 6.
Yeah. Don't do it yet.
Okay. On the top, we will have 12 plus 6 times the square root of 6. On the bottom, we will have 4 plus 2 square root of 6. And when we distribute the negative square root of 6, we will have negative 2 square root of 6, negative square root of 6 times positive square root of 6 is negative 6. Okay, these middle two cancel, and we have 4 minus 6, which is negative 2. On the top, we have 12 plus 6 square root of 6. Okay. I would consider this answer to be mostly done and mostly correct. Look at the whole number pieces. Ignore the stuff under the radical. Just look at the stuff that isn't under the radical. We've got 12, we've got 6, and we've got negative 2. Do 12, 6, and negative 2 have anything in common? 2. In fact, let's do negative 2. So 12 divided by negative 2 is negative 6. Positive 6 divided by negative 2 is negative 3. We still have that square root of 6. And negative 2 divided by negative 2 is 1. Do we need to put over 1? No, we do not. So this would simplify to negative 6 minus 3 times the square root of 6.
Can you do a negative 9?
Oh, hey, that's a really good question. Could this simplify to negative 9 times the square root of 6? It could not. Because what's happening between the 3 and the square root of 6? Multiplication. And according to PEMDAS, multiplication is definitely more powerful than addition or subtraction. You have to do multiplication before you add or subtract. So we would have to do negative 3 times the square root of 6 before we combined it with that negative 6. So you cannot combine those two. They have to stay separate. What if we ended up with something that looked like this? 9 plus 12 times the square root of 3 over 6. I just totally made up an answer. But what if this is what your answer looked like? If you look at the whole number pieces, what do 9, 12, and 6 have in common? 3. 9 divided by 3 is 3. 12 divided by 3 is 4. It does not affect the radical. And 6 divided by 3 is 2. So that's how that type of problem would simplify. So it might be worth making sure that's in your notes just so you can see how that simplification might occur. All right, on this section, we are adding and subtracting rational exponents and radicals. In order for rational exponents to be like terms, they must be exactly the same. So do you see how this 4 to the 3/4 is exactly the same as this 4 to the 3/4? Okay. I want you to think of 4 to the 3/4 as chocolate chip cookies. So right here it says we have 5 chocolate chip cookies. Right here it says we have 3 chocolate chip cookies. If we subtract, what is 5 minus 3? 2. So we have 2 chocolate chip cookies. Really, this is just like doing 5x minus 3x equals 2x. It's not x, it's 4 to the 3/4. And as long as both of those things are 4 to the 3/4, you can combine the coefficients. So take a look at number 2. What do you think the answer to number 2 is?
10. 3 to the 2/3.
10 times 2, or 3 to the 2/3. Perfect. Okay, number 3. You can add and subtract radicals if the x, or the index and the radicand are exactly the same. In number 3, are these exactly the same? They are not. So first, we have to take this cube root of 81 and simplify it. So using our perfects chart, this is pretty easy. We've done this before. Look in the thirds column at numbers smaller than 81. 64 is the first number smaller than 81. Do you think 64 is going to work?
No.
It's not even half of 81. That one's not going to work. How about 27? 27 times what is 81? 3. Hey, helpful hint. This one, my OneNote decided to not help me there. This one, this cube root of 3, notice the other one says cube root of 3. Maybe that's a hint for how it's going to be simplified, possibly. The cube root of 27 is 3. So the cube root of 81 becomes 3 times the cube root of 3. And then we still have minus the cube root of 3. What number is in front of this second cube root of 3? A 1. So you get to do 3 minus 1. What is 3 minus 1?
2.
2. 2 times the cube root of 3. I would like you to try number 4 on your own. Pause the video, try it on your own. You need to start by splitting up this cube root of 625, and then you can add or subtract them. Okay, some of you are going to think I'm a little bit silly because you're looking in the thirds column, and there's probably a number in the thirds column that pops out at you as the most likely number. But in case that doesn't describe you, I look in the thirds column, and the biggest number that is smaller than 625 is 512. 512 isn't even half of 625, so that one's not going to work. So I try 625 divided by 343 decimal. 625 divided by the next one, 216 decimal. 625 divided by the next one, 125, and that one works. Now, you're probably thinking, well, come on, it ended in a 5, so it has to be 125. Well, yes, that is a good hint to pick up on, but in case your brain doesn't work that way, it's totally fine. And one more time, this 5 should be the same as whatever the other radical is, so that can be a hint to help you break this up. The third root of 125 is 5, so this thing becomes 5 times the third root of 5, and then we have minus 1 third root of 5, and 5 minus 1 is 4. So 4 times the third root of 5.